I'm going to say a couple things. Hello, am I on? Okay, I'd like to welcome everyone to our third webinar here at the School of Science and Engineering at Tulane University. And the topic today is the undergraduate experience. Recently, Tulane had two task forces that published reports at the request of President Mike Fitz. And one of those looked at the undergraduate experience, and the other one looked at academic, scholarly collaborations at Tulane. So I've decided that each of the webinars this year would cue off of one of those two topics. So this one's the one on undergraduate experience. Before we get started, however, we do a little poll. And so this poll will be on the screen for 30 seconds, and we'd like for you to please take this opportunity to fill it in. This helps us to understand who our audience is, and then we can tailor our webinars to the people that are tuning into them. So I'll give you 30 seconds to fill out the poll. Okay? Okay, great. So let me talk about the undergraduate experience at Tulane and in the context of the School of Science and Engineering. I'd like to start off by, again, referring to our mission. And you've seen this mission before, but I thought it would be important to start the webinar with it to just sort of set a context. So the mission of the Tulane University School of Science and Engineering is to provide outstanding opportunities for learning and discovery in science and engineering. And we focus on learning and discovery rather than teaching and research, because learning and discovery are obviously the outcomes of teaching and research, and we want to make sure we focus on outcomes in school. But also, we fostered an environment here which I believe is a very unique environment. Not only does it integrate science and engineering in our school, but it also is an environment which is student-focused and research-intensive. That's relatively rare. There are a lot of research-intensive universities in the country. The number of them that are student-focused, like Tulane is relatively small. So that in itself is a rather unique feature of our school. But we're also transdisciplinary, and I like the word transdisciplinary, assuming that that is a word, because what it means is that everyone is deep into their discipline but works across disciplines. And so transdisciplinary is a very important aspect of the school, and it will be the subject of my second webinar this year, the one in the spring. We're also entrepreneurial, and we're responsive to the needs of the community. So all of those are the aspects of our environment, and I think it's important to put everything into that context. In order to achieve that mission, we have a number of things that we need to do. One of those is to position ourselves for a leadership role in a world where science and engineering are increasingly interconnected. Secondly, we need to provide students with the broad educational experience and a deep understanding of science and its applications and impacts. We have to have departments that are of sufficient size and critical mass to be competitive for international recognition of their academic programs and their research impact. We have to have strong interdisciplinary ties among the departments of the school and with partners throughout the university and beyond. We need to promote a climate of cultural diversity and global awareness, and as I said, we need to be responsive to the needs of our community. Let's take a look now at what the undergraduate student body in science and engineering looks like at Tulane, and what the trend has been since the inception of the school shortly after Hurricane Katrina. As you can see, the total number of undergraduate students at Tulane University with a primary major in the School of Science and Engineering is now 1,800. That has grown steadily since the low point, which was a couple years after Hurricane Katrina, of under 1,300 students. Now, I'd like to point out that I've made a point there of calling these primary majors. This is the official data from the Registrar's Office, and the Registrar's Office reports all of the Tulane data in terms of primary majors. But Tulane has a growing number of students who are double majors. And if you look at the total number of double majors, where the secondary major is in the School of Science and Engineering, there are about 200 to 300 more students who are majoring in science and engineering as a secondary major in their double major. That includes about 50 students who are enrolled in our coordinate major in computer science, which has to be coupled to a primary major, and where the students in their senior project need to apply computer science to their other major. So we have over 2,000 students who are majoring in a science and/or engineering program at Tulane, fully 1/3 of the student body here at Tulane. The next slide shows what our undergraduate degree programs are. These are the undergraduate degree programs that we currently offer. You can see that there are a number of Bachelor of Science degree programs. In fact, we offer Bachelor of Science degrees in virtually all of the science disciplines. We also offer 3 Bachelor of Science in Engineering degrees. Those would be ABET accredited engineering programs. That would be biomedical engineering and chemical engineering, both of which existed before Hurricane Katrina. And then the engineering physics program, which was added since Hurricane Katrina and is ABET accredited as well. A 4th program, computer science, as I mentioned earlier, is a coordinate major, and that program is new and already has 50 students enrolled in it. There are 2 other areas that we're exploring at this time. I put together a task force that's been looking at the interface of the geosciences and engineering, and that task force reported to my board of advisors recently, and we will be looking at putting in place such a program in the near future. And then the other program that we've been exploring is neural engineering, because we're extremely strong in the neurosciences, and neural engineering is an engineering discipline of the future. So those are our programs. But in engineering or science or any undergraduate experience of any kind at a university is more than simply the courses that you take and the credits that you sign off for. There's an experience that goes beyond the classroom. And so what I'd like to emphasize is what that experience is and how we implement it here at Tulane. First off, the next slide shows the non-scientific technical skills that have been listed by ABET as part of their criteria for engineering accreditation. Now, these are part of the ABET criteria, but they apply to the sciences equally well, and they apply to all disciplines equally well. So these are all part of our curriculum as well. An understanding of the impact of scientific and technical work in a global, economic, environmental, and societal context. An ability to communicate effectively. An understanding of professional and ethical responsibility. An ability to function on multidisciplinary teams. Again, I like the word transdisciplinary. I think that any student that comes out of Tulane needs to have a deep, deep understanding of their discipline, but also that ability to work with others on multidisciplinary teams. A knowledge of contemporary issues, and a recognition of the need for and an ability to engage in lifelong learning. Now that's one that I think that I need to emphasize very much. Things change very quickly nowadays, and we want our students to be able to learn throughout their career because they're going to need to do that. So those are the non-scientific technical aspects of the curriculum, and those are part of our engineering curricula because they're ABET requirements. We are working to make that part of all of our curricula because those are skills, there's the so-called soft skills that students need in order to be good citizens and to excel in their professions. The next thing I'd like to do is talk about the curricular experience that we call the Grand Challenge curricula. Recently, a number of universities in the country began offering what they called a Grand Challenges curriculum. And this Grand Challenge curriculum was written up by the National Academy of Engineering. Again, I think it applies equally well to scientists as it does to engineers. When I saw the components of a Grand Challenges curriculum, it immediately occurred to me that these are things that we do at Tulane. And so Tulane University is entering into the consortium of the Grand Challenges universities, and we are going into that consortium with all of the components in place, and it's just a matter of continuing to build on those. So let me tell you what the components of a Grand Challenge curriculum are. One of them is a creative learning experience connected with the Grand Challenges, such as research or design projects. Now, the Grand Challenges, as articulated by the National Academy of Engineering, really are in areas that you would expect: energy production, environment, health, global health, Security. Those are, and there are others, but those are the areas that pose incredible challenges here in the 21st century. Following on the lead of the National Academy, many other organizations have come out with their lists of grand challenges. So it's become quite fashionable for everybody to have a list of grand challenges of the 21st century. But those grand challenges invariably focus on health, energy, the environment, security, etc. The same themes keep recurring. In the School of Science and Engineering at Tulane, we have two cross-cutting themes. One of those is health, cognition, and bioinnovation, and the other one is energy, environment, and sustainability. And in those areas of emphasis in our school, one finds all of the grand challenges. So students who do their senior design project in any of these areas, or who work on research projects in any of these areas, are fulfilling the first condition of a grand challenge curriculum. We have 250 of our students right now working on research projects in research labs. And of course, many of our students, especially the engineering students, are required to do design in their curriculum as well. So this is pervasive throughout our curriculum. The second is authentic experiential learning with clients and mentors that include interdisciplinary experience in fields such as public policy, business, law, medicine, ethics, and communications. The number of students in the School of Science and Engineering that are doing internships is growing quite rapidly. And this has become a big part of our culture as well. In fact, some programs, like the engineering physics program, literally require an internship as part of the graduation requirement. So internships are something that we've been emphasizing for a long time, and we'll emphasize more as we embark on being a Grand Challenges university. The third is entrepreneurship and innovation experience, such as a startup of a new venture, dissemination of technology, or coursework in entrepreneurship. Again, you've heard me talk about this before on these webinars, but the culture of entrepreneurship is growing in the School of Science and Engineering. The number of patents is growing very, very rapidly, and the number of startup companies based on technologies coming out of the School of Science and Engineering, both faculty and students, is growing at a very rapid pace. I can name off the top of my head 10 startup companies in the New Orleans area alone that have come from science and engineering technologies over the last 4 years. So that's another big part of our culture. The next is global and cross-cultural perspectives gained through experiences that promote involvement with globally complex issues in unfamiliar environments, such as a semester abroad. Tulane has always been known for its study abroad programs, and those of you that are watching this webinar that are alumni know that. We have been working in the School of Science and Engineering to make those study abroad experiences more applicable to the science and engineering students. Oftentimes, science and engineering students are reluctant to study abroad because it slows down their time to the degree, but we've been working to try to make that more seamless. More and more of our students are doing study abroad, and we now have workshops for students to learn how they can get involved in those programs. And the last one is development of social consciousness through service learning, such as problem-based community projects that foster an appreciation of the impact of science and engineering and their role in serving human welfare and the needs of society. Well, I don't really need to say much about this one. Tulane is the only research university in the country that has made public service, community public service, an undergraduate requirement. And the requirement here is that all of our undergraduates must have 2 such experiences during their undergraduate program. So the Grand Challenge criteria are ones that we clearly meet, and we will be working going forward at making it, having students actually enroll in the Grand Challenges curriculum, keep a portfolio of what they're doing, and they will recognize them as Grand Challenge scholars. I mentioned at the very beginning the task force that President Fitz put together. He put together 2 task forces, but one of those task forces was to look at the undergraduate experience. I thought it was interesting that the President, in the 2 task forces that he chose to constitute at the beginning of the year, that one of them was the undergraduate experience, and the other was scholarly collaborations. Both of those are strengths of the School of Science and Engineering, and I think it also is a testimony to the fact that we are a very collaborative, research-intensive university where the undergraduate experience is one of our core values. So I'm not going to go through the entire report, obviously. This report is online. You can find it at the President's website, on the Tulane website. But that committee, the task force, came up with recommendations for the university, and those universities fell into 5 categories. And those 5 categories are interesting. The first 2 are articulate the core values of the undergraduate experience and strengthen the position of Newcomb-Tulane College. As you probably know, we have one undergraduate college at Tulane, Newcomb-Tulane College. All undergraduate students are admitted to Newcomb-Tulane College, are enrolled in Newcomb-Tulane College, and receive their first advisor is assigned to them in Newcomb-Tulane College. What that does is it allows the university to set core values for all of our students. So to basically answer the question, what is a Tulane graduate? What are the qualities of a Tulane graduate that all Tulane graduates share? It also allows optimal flexibility for the students. That's why we have so many double majors and minors and various kinds of combinations, because the students have complete flexibility in how they choose their subjects. Of course, within the constraints of things like ABET accreditation. So those are very important. But I think also the others are quite interesting. They increase the quality of academic instruction. We take great pride in the academic instruction here at Tulane, but nobody's perfect, and we're constantly seeking to improve that. And so this has a lot of recommendations as to how we can use digital tools, as well as new classroom pedagogies to address the changing learning styles of our students and to make teaching more effective. The next one is address immediate wellness issues. This includes both physical health as well as mental health. There's been a lot of publicity recently about mental health issues among students here at Tulane and around the country. We take that very, very seriously, and the university is working very hard to make sure that students who have any kind of a crisis whatsoever know where they can get help and can get the help they need quickly. And the last one is to solidify residence life and co-curricular engagements. What this is all about is making the dormitories not just places where students sleep, but places where students have a co-curricular experience, where there's workshops and lectures and seminars, etc., so that their academic life doesn't just end when their last class ends or when they finish studying for the night, but that the dormitory itself is a learning culture. We have several dormitories now at Tulane where faculty members are in residence. And several of those faculty members, by the way, are from the School of Science and Engineering. And so these faculty members move their families into the dorm, and they become the leader of sort of the co-curricular life of that dormitory. So I hope I've given you an overview of the undergraduate experience that goes beyond the classroom in terms of not just science and engineering, which of course is the heart of what we do, but also those soft skills that go beyond science and engineering, the experiential part of learning that rounds out a well-formed curricular experience, and then the student life issues, the issues that the university as a whole is addressing to make Tulane a place in which our undergraduates can thrive. Well, you've heard from me now. Better yet to hear from a student. So I have a student here with me today from the School of Science and Engineering, and I'm going to turn it over to her. And so I'd like to introduce Kristen Hanrahan. And Kristen is a senior here at Tulane University. She's majoring in engineering physics, and she'll be receiving her Bachelor of Science and Engineering degree in engineering physics this coming May. And so, Kristen, can you tell us a little bit about yourself and your experience here at Tulane University?
Okay, hi everyone. Like the dean said, I am Kristen Hanrahan. I am a senior in the engineering physics program here at Tulane. I just want to give you a little bit of a background of how I actually ended up here. So I was born in New Orleans and then moved to Central California and lived most of my life there. When it came time to look for schools, Tulane was always on the radar, and I eventually decided it was the best fit for me to get close to my extended family, but also return to the city of New Orleans and everything here. As a freshman, I was pretty in between majors. I knew I wanted something, an engineering major, so I looked pretty extensively into chemical engineering and engineering physics. Overall, the engineering physics program, for those of you who don't know, it's a pretty new program here at Tulane. a strong focus in applied sciences. So we take a lot of physics courses, but also a ton of engineering courses, obviously. And I really like the flexibility of the program and the things that I would be able to do, which I'll touch on in a second. But it was just overall the best fit for me. So I know that the dean went over the Grand Challenges curriculum. I want to take a second and go through those and my personal experience, my personal undergraduate experience, the topic of this webinar. So first, the most important thing to me has been the design projects. So in my major, we're required to do 2 separate design courses. One is a sophomore and one is a senior. So our sophomore design tends to be a bit more creative. We were given the semester and about $100 to design and prototype anything we wanted. Someone in my group had recently seen the Seinfeld episode with a car periscope, so naturally that's what we decided to do. And by the end of the semester, we actually had a mostly working PVC periscope with some nice little pulleys to raise it to a height of about 6 feet, I believe. And we actually were able to mount it in the sunroof of my car and drive down St. Charles around 40 miles an hour and still see somewhat clearly out of the top of our periscope. So that was obviously a really fun project, but it was a great way to incorporate the design and multiple iterations and just kind of the engineering approach overall. So that was definitely a highlight. Now as a senior, our senior design project is a bit more serious. We have to work with an industry partner. So I'm working with a local startup called Connected Earth Sciences, and we, over the course of the year, will develop a sensor system for wetlands data monitoring. So this project is a bit more focused. We have weekly presentations, progress reports, lots of separate meetings outside of class. We can't just get it all done at once, but it's really teaching, I think, all of us a lot. There's, I think, 12 to 15 people in my design class right now. We're all working on separate projects with different industry partners. So it's great to hear from them and what challenges they're having, as well as be able to brainstorm collectively and fix all of our problems with a fairly limited budget, but plenty of time. So overall, the design projects are definitely what I consider to be one of the most important parts of my engineering physics curriculum. Moving down, interdisciplinary experience. I personally, well, as a Tulane, you have to take a lot of core curriculum, so a fine art and humanity and social sciences. So we all have done that. I personally gained more interdisciplinary experience through my internship. So the dean touched on that engineering physics we have to have an internship. It's required. So for my first summer internship, I worked with a company called Ophooks Products in Covington, Louisiana, and they're a manufacturing company, and they use a lot of SolidWorks. So when I was there, I was using SolidWorks every day, all day long, and as I and the rest of the engineers noticed that using trying to add their part information and ordering information into the SolidWorks toolbox, so their standard nuts, bolts, and other hardware, was pretty difficult. They could add the information, but it wouldn't always be transferred. Their tool room had maybe 3 of the same screw, just under 3 different part numbers, so ordering was a hassle. And assembly, according to the shop foreman, assembly was really hard. So my project was to actually revamp the entire system and design a new toolbox with the same parts. So it's about 3,000 standard parts, but separately modeled, not part of SolidWorks, and had to go through purchasing, the engineers, the tool room, the shop foreman. So that actually gave me a ton of experience in communicating across those different departments. I mentioned that my senior design project is with this local startup called Connected Earth Sciences. But through both of our design classes, we talk a lot about entrepreneurship, and I know a couple project groups plan to take their products to market if possible, but a lot of focus on what a startup might entail and the difficulties that you might face, both through those design classes and other humanities. A big thing is a semester abroad. Unfortunately, I was not able to go abroad through Tulane, but I did have a second internship experience with a company called Furlough in Spain, in northern Spain, and that was a lot of fun. It was over summer, but I also got a ton of work experience. So I know from my personal experience and from many friends, most of whom who have studied abroad with Tulane, the global experience is really something of value and definitely expands all of our horizons a little bit, even hearing the stories from afterwards. And then service learning is obviously a big component of the Tulane curriculum. So the dean mentioned we do have a first tier and a second tier service learning. So for my first tier, I worked with the Boys and Girls Club of Southeast Louisiana and spent 20 hours throughout the semester going there, helping these kids with their homework as soon as they came to the center from school. I played a lot of flag football, a lot of hopscotch, but just kind of overall hanging out with these kids. And they all of course, want to know about college and school and what Tulane's really all about and how can they get into Tulane as a fourth grader. So lots of fun. Again, the second tier is normally more serious. So I just completed mine with Higgins High School on the West Bank. That was a bit more involved. So we visited the class several times throughout the semester, and they were each student was working on their own independent research project. So our job as Tulane mentors was to go, and we each had a group of 5 or 6 students, was to go to the high school to have them work through their problems with us and offer solutions. We talked to them about, coming up with a successful elevator pitch for their project, appropriate study designs, how to actually write up their report and give a great presentation, things like that. So we were teaching them a lot, but they also they asked us about our design projects, and they came up with some pretty great solutions, really creative solutions that we might not have thought of. So they were also a huge help for my class's senior design projects. So that should hopefully give you an idea of my personal grand challenges and undergraduate experience. I believe now the dean and I are going to take your questions.
Yes, so it's time for questions. So we'd like to spend the rest of the time with questions. The way this works is that you send your question in to either you can address it to me, you can address it to Kristen, you can address it to both of us, however you want to do it. So let's see, do we have any questions? So I see the first one is for me. What can you tell us about the timeline of completion for the makerspace and how will it benefit future students? I'd be happy to answer that question. So I mentioned earlier the entrepreneurial climate here at Tulane. We have a lot of students that have started to develop products and form teams and sort of pre-incubated companies, etc. Well, we've decided to fuel that excitement by giving them a place where they can do that. So there is for those of you that went to Tulane, you might remember the old machine shop, which by the way was originally the blacksmith shop at Tulane, that had become the machine shop. We're in the process right now of completely remodeling that space to turn it into a makerspace. It will have a mezzanine where students can sit at workstations or tables or whiteboards and come up with their ideas. I'm told that that's called ideation. And this will have a place to ideate on this mezzanine. And then there will be a ground level where there will be manufacturing tools like 3D printers, laser cutters, etc., where they can build their prototypes. And there will be lots of room for them to interact with one another. We view this as a multidisciplinary space where students from all different disciplines will come, and maybe little nascent companies will be formed. The timetable is to have it ready to go by next summer. In fact, right now they're working on the final design, and construction will start soon. In the meantime, a corner of the space has been marked off for a temporary makerspace, and so there is activity going on there now, and the students have found it. I understand in talking to Kristen that she found it, so I might pass this on to her and maybe have her address her experience in the makerspace. But as of next summer, it's going to be a show place on the campus, I believe, and very, very active.
Yeah, we are all very, very excited for the makerspace. Even right now, with its kind of limited little corner, there are, I believe, 3 3D printers and 2 laser cutters, which has been extremely helpful in our prototyping. So we can, draw our design and talk about it all we want, but then if we can go out and cut it or print it and have it in our hands and play with it, it's been such a great resource. There's student workers and they're always super helpful, and they're there mostly every day, or most of the day, every single day of the week. So whenever my group needs anything, and I know other groups too, we can just run in and say, hey, can you help us? we have this model, what do you think about it, and can we print it? So it's been a really great tool for us. Oh boy, for me. Okay, so how have you been able to have a life outside engineering physics through extracurricular activities? I tend to bite off more than I can chew, but it's meant that I've been really involved on campus and able to do a lot. So currently I'm on the Tulane cheerleading team. I have been for 4 years now, and I'm also a member of a Pan-Hellenic organization here on campus. It's been a little interesting. I know people think engineering majors are a lot of work, and they are, but it actually has allowed me to get a lot better time management skills and organizational skills, so I can make sure I am everywhere that I need to be at the right time and still get all my work done. So definitely something I encourage. You meet a ton more people than you would just in your major or just in your dorm. It's been overall really great for me.
Okay, this one's for me, I guess. Engineering has opportunity to work with others. How is this supported? Engineering has opportunity to work with others. How is this supported in science curricula? Oh, I see. Yeah. So if you look at what our scientists are doing, many of our scientists, a lot of them are in research, and so research projects are interdisciplinary as well, and so that's a tremendous opportunity for them there. I think that what's really interesting to me is that a lot of the teams and products that have come out of the School of Science and Engineering have indeed come through the science side of the house. And so we have many scientists who work with engineers in terms of products and that sort of thing. Scientists are also working with the medical school, with the School of Public Health, and with others on interdisciplinary projects that require basic science in the health fields, etc. So I would say that the science students are every bit as involved in working with students from other schools as the engineering students are. I'll give one other example, the environmental studies area, where you have a lot of science students working closely together with students in the liberal arts and in social work, etc. So yeah, they're quite a. I'd say that the working with others, the interdisciplinarity cuts across every discipline in the school, and I would say that it cuts across every discipline at Tulane, as a matter of fact.
Okay, for me, what has been your favorite class, experience, or opportunity with science and engineering? Well, I already went into my sophomore design in my car periscope, so that was really great. Another highlight for me was actually an independent study course I took. So with Dr. Schuler on campus, he runs the physics labs. If you took Physics 101, you probably had him. He allowed me to do an independent study class called Design to Build. So throughout the project, or throughout the semester, he just gave me a few smaller projects to get an idea of different design methods and things like that. So through that semester, I 3D printed a Nerf gun, always exciting, and he helped me figure out a circuit for a speaker. So I laser cut the box for the speaker, put in all the components, soldered it all together to be able to play from like a headphone port, so I could play music from my phone on my homemade speaker. And we also started to get into microcontrollers, so that was a great way for me to get a little bit of experience in a lot of different things and also get course credit for it. So independent study was great.
What was your favorite class?
My favorite class was definitely dynamics. Dean Altiero. No, it really was though. It was very useful and well taught. No, I agree though. It was my favorite. That and statics as an engineer.
Talk about fishing for a compliment. Okay, next. Okay, for me, what advice do you have for students who want to succeed in the current tech economy? That's a great question. As you know, it's pretty obvious that technology is accelerating rapidly, and the changes happen daily anymore in our economy. And this has caused a lot of people to have obsolescence in their careers, because the things that they do and that they do well are no longer needed as technology displaces it and the economy moves on. Earlier, I listed those skill sets that we try to imbue in our students here at Tulane. I would say that one about lifelong learning is really important. if we get no other message across to our students, they need to understand that what they're learning here at Tulane, more than anything else, is how to learn. And that they've got to, whatever skill set they develop here at Tulane is going to serve them well, but it's only going to serve them well for a short time, because they're going to put themselves out of business through their own creativity unless they can keep up with those changes and always adapt to what is the next thing that needs to be done. So I would say lifelong learning is really, really important. I'd also say, though, that you need to really be good at what you do. When you pick a discipline, you can't be shallow in that discipline. You have to understand that discipline in depth. But you need to have those soft skills as well. You need to be able to communicate. You need to be able to work with others. And you need to understand the implications of what you do. You know, in our society, with the tremendous changes that technology is bringing to us, there's lots of room to do things wrong, or to do things that don't serve society well. And so we want also, you know, in order to be successful, you need to be a good citizen. And you need to always be working for the betterment of the human condition. But again, lifelong learning is very, very important, especially with the pace that things are changing now.
Okay, for me, what are your plans post-graduation? $1 million question for all of us seniors. So I plan to go into industry. I'm currently reaching out to my previous internships, particularly Blade Dynamics, so a local company. I hope to stay in the area and find a successful full-time job in industry. But it seems to be pretty split between students wanting to go into grad school and into a full-time job right away, especially in the engineering physics program. A lot of students want to go into grad school and further specialize. So those are.
Yeah. Let me add to that what she just said. I think that, so the last year's engineering physics class that graduated, I looked at where they went, and literally half of them went to graduate school and half of them went to industry. It was really, really rather interesting. And the ones that went to graduate school went into very different disciplines when they went into graduate school. Some went into mechanical, electrical, civil, programs of materials engineering, etc. So, but that's been, that major in particular, I think, is kind of a microcosm of the university, sort of the grad school route and the business route, the industry route. For me, what resources do you plan to offer students to accomplish the Grand Challenges curriculum? Yeah, that's another good, really good question. As I said, a lot of the Grand Challenges curriculum we do as a university. I think that we just never called it that. These are just components of our curriculum that it turns out the National Academy has recognized as being very important. As we go to become a formal member of this consortium, what it means to become a formal member of this consortium is that you basically demonstrate that your students did these things, and then they get certified as having done a Grand Challenges curriculum. So one of the things we're going to do is we're going to help them to build to keep track of this, sort of have a portfolio of their successes where they will log in what they've done in each one of these areas, and at the end of the day be able to show what those experiences were and how they contributed to their education. We will continue to work very hard to identify more internship opportunities. That's always a challenge, but we've been finding more and more of those, and as you heard from Kristen, some of our majors require it, so it's become imperative that we find these internship opportunities for them. The study abroad, Associate Dean Beth Wee has organized this workshop for the students called Get the Scoop on Study Abroad, where she hands out ice cream. But they also come in and they tell all the students about study abroad opportunities, so that's another thing that we're doing, and finding more of those study abroad opportunities for them as well. That's also always a challenging thing. So, but in each one of those areas, we're going to be very, very proactive, and plus we're going to become more, we're going to document more what students are doing, so that at the end of the day they can look and see, well, these are the experiences that I had outside of the classroom that prepared me for the future.
Okay, for me, how did you uncover your foreign internship opportunity? So I actually went to Get the Scoop on Study Abroad with Dr. Wee and looked at all these summer abroad programs that Tulane was offering. One in the south of Spain particularly stood out to me. but I couldn't actually make it work. So my summer internship with Allpacks, actually the company in Spain was a sister company, or a partner company, I guess. So they were able to kind of give me that reference and point me in the right direction. But I wouldn't have been interested if I hadn't gone to the study abroad and been really intrigued in the Southern Spain program. Yeah.
This is for both of us.
Oh boy.
How are SSE students learning to thrive in a connected business world? Want me to take that first?
You first.
Well, I think that I'm not sure exactly what connected business world means, but our students, we've made a concerted effort to increase our ties with the business community. So we've built more and more partnerships with not only with big companies, but with small companies, with startup companies, etc. And so these companies, and we've welcomed them in to Tulane to interact with our students, to provide them with internships, to meet with student groups. A number of companies now have sponsored projects for students. In fact, we had a recent celebration where we thanked all of those companies who had sponsored projects. These are real-world projects for our students to work on. We've been working with career services a lot to connect our students with companies. Our board of advisors of the school, the members of the board, one of their big projects for the last several years has been to improve career services and industry relationship services for our students, for science and engineering students in particular. And so I think that we put I know that we put much more emphasis lately on students going into the business world and learning how business functions and what their role would be. I think Kristen's a perfectly good example of that. In fact, the fact that she's been focused on that career path.
Right, yeah. The Career Center actually just started a new program. It's called the Senior Year Experience. So seniors can apply, I believe, and then they'll set you up with a career advisor that you meet with weekly to go over your plans for the future, and they have a ton of contacts. Also, all the networking fairs that Tulane puts on. The industry partnerships are huge. Specifically in my design program, these companies reached out to Tulane and said, we have this project, can your students help us? So it's been great to go back and forth with all of these different companies and hear about the things they're doing and how we as students might fit into their needs and potentially jobs afterwards.
Okay, this one's for me. How are students made aware of research opportunities as undergrads that are related to their discipline? That is a really good question. So, you know, it's hard to do that. We've come up with some things. We have a Center for Engaged Learning and Teaching at Tulane now, and they post these kinds of opportunities for students to find them. You know, really, to be honest with you, the way these things happen is that the students find them. The students get to know the faculty. They get to know what the faculty are doing. And they take the initiative to walk up to a faculty member and say, I really like what you're doing. Can I work in your lab? And hopefully, the PI has room in the lab for the students. And one of the things I can tell you is I discovered this the day I got to Tulane. Faculty members love to have undergraduate students working on their projects here. At first I thought that was very magnanimous on their part, but then when I found out how good the students are, I realized that they're just taking advantage of an opportunity here to get some great talent into their lab. So faculty members will take them on if there's room in the lab to do that. I'll tell you the one area where we did run in, where we struggled for students to find research opportunities was in the life sciences. In the physical sciences, I think we've been really good at matching up any student that wanted to do a research opportunity with an advisor, or them finding an advisor that they wanted to work with. We have so many life sciences students that even though we have an awful lot of life sciences research, the number of students that want research opportunities just overwhelms us in terms of what our capabilities are. So there we've been very fortunate that the medical school has opened up their arms to our undergraduate students as well. And so the students are finding many, many opportunities down there. And every time I go down to the medical center, I see more of our undergraduate students on the shuttle bus headed down there to work on research projects. So it's a thing of the student taking the initiative, which is not a bad thing. I think students have to learn how to take the initiative like that. So, but we don't do formal pairing of students with them.
Okay, for me, what piece of advice would you share with an incoming student that you wish you had known? Let's see. I think just taking advantage of all the resources Tulane has, and definitely being willing to talk to professors and reach out to them for research or for independent study. If there's something you're interested in, there's probably a professor who is very knowledgeable about it and can help you get there. I think definitely as an engineering major, getting as much experience as possible is great through internships and things like that, but also in different tools. So I've taken basic programming classes, some like 3D modeling, a little bit of AutoCAD, a little bit of microcontrollers, things like that I think really make I can use that basic programming in some of my other classes, but it's also a great thing to be able to know how to do. So just kind of taking advantage of the different tools that Tulane has and companies around the area have too.
Is there a forum for students to connect or create a team with other students as part of a transdisciplinary program? For example, psychology and engineering students. Okay, so we have I got a great example actually. Now that so first off, yes, we do. We have lots of activities that bring students together in terms of poster sessions and other kinds of things. One thing I would like to single out is the Novel Tech Challenge, which is something that we just started last year. And this is a challenge where we put up posters around campus that if you have an idea and you want to see if you can turn that into a product of some sort, that you can enter the Novel Tech Challenge. And we strongly encourage interdisciplinary teams to enter into this competition. Well, last year was the first year that we had the competition. We had, I believe, 20 or so entries into it. We selected 10 teams, and those 10 teams were given some resources. They were given access. They weren't given access to the makerspace because we didn't have it yet, but they were given access to the tools that are going into the makerspace in various locations. They were provided with an on-campus mentor. They were provided with a alumnus mentor from industry. We had a competition, and there was a winner, and they got an award to help develop their product further. Interesting thing about that is that the teams that formed were from all sorts of different disciplines, and it's really interesting that whoever the caller is asking about psychology and engineering must have inside information that one of the best teams was actually a team that was started by a psychology student and an engineering student. But then those teams become they get the word out that they're developing this product, and then they add team members, and the team members might come from marketing or some other or some other discipline, the arts, whatever. And at the end of the day, we literally have teams with products, with the skill set necessary to make that product, market that product, business plan, etc. So that's one thing that we've done. But there are many, many forums. We have Research Day, where all of the students have posters where they all come and see each other's posters. Each one of the disciplines has their own research days that students are invited to. But I would say the one for the school as a whole is the one where students from all different disciplines are going to be there. They're going to see what other students are doing. And what happens is they might see something. I think that the example of the psychology student and the engineering student, they might see something where the psychology student says to the engineering student, you haven't taken into account human factors here, et cetera. So that sort of activity, we do have a lot of interactions where students can come to. In fact, I would go so far as to say that that's really the whole idea of the School of Science and Engineering, is for these students to simply be learning and discovering in this environment where they just keep running into students from all of these other disciplines who have a different way of looking at that same subject. Oh, for me again? are there specific scholarships, grants from SSE available to existing students? Well, so the way scholarships, so there's, I don't know, there's one, scholarship is one thing, grant is another thing. The way scholarships work at Tulane is that the students are awarded the scholarship from the university. They're not awarded the scholarship from a specific school. Once they've been identified as a scholarship student, they are then assigned whatever scholarship is appropriate for them. So if a student gets a scholarship, we will look at that student. We will be told this student has earned the scholarship. Which scholarship that SSE has applies to that student, and then there are certain scholarships that were given for SSE students. There are certain scholarships that were given for liberal arts students, etc. So they're assigned in that manner. So we don't pick the scholarship students, but we then assign the scholarships to them. Kristen here, for example, is a Dean's Honor Scholar, which is the Cadillac of scholarships. And so Kristen, that was easy. When we got Kristen's name, we just said, Dean's Honor Scholar, right? But that's how those are assigned. In terms of grants, we do have ways of funding student projects through various mechanisms. So if students have a project or something that they want to do, there are ways for them to get grants from us, from the Office of Student Organizations, Newcomb Tulane College, Newcomb College Institute. So there are all kinds of opportunities for entrepreneurial students to apply for and to get funding for various kinds of projects that they're working on or events that they want to host. Can we discuss any initiatives in math and opportunities to enhance the classroom experience? So mathematics, that's an interesting question, because one of the things that we're looking at in the school right now is our digital learning strategy. And what I mean by digital learning strategy is how can we use technology to better better deliver our curricula, our courses, etc. While that's a work in progress, I think what we have concluded is that for us, for the School of Science and Engineering, digital learning would fall into two categories. One is, how can we use it to enhance the undergraduate experience? Because if you look at what the undergraduate experience is at Tulane, the undergraduate experience is students that are a certain age group that come to this university to go from being kids to being adults, and that whole experience is a very personal, hands-on kind of thing, right? And so in that sense, we want to use digital learning to make that experience better. Students learn differently today than they did back when I was in school, I can tell you that. And so a lot of that's come about because they've grown up in a digital environment. And so we are looking at enhancing the educational experience through that. With respect to math, at the graduate level, by the way, we're looking at master's education. And there remote education makes a lot of sense for us. If we're very strong in a particular area, to deliver a master's by the internet is a good way to go. In mathematics, we have hired some new professors of the practice. Professor of the practice is a professor with a PhD who's focused on teaching. And we have a couple of these professors of the practice that are actually looking at the undergraduate math experience, in particular calculus. And what they've done is they've gotten some digital tools, and they've taken all the calculus professors together, and they've been looking at how can they make calculus. Calculus is never going to be a wonderful experience, I suppose, but how do you make calculus an experience where the students are happier with the education that they're receiving, and where the outcomes are better? And so they're doing some very creative things. As a matter, one of the things that had happened in calculus was the number of students taking calculus is so great that being able to give them meaningful exams that could test whether they were not just learning a derivative, but were learning how to do mathematics, how to apply mathematics, was harder and harder to do because you needed to have them solving problems. And grading all that could become quite cumbersome. Well, these faculty members got a software package. They put together a process, and they've made it so that they are doing a very effective job of giving comprehensive exams, grading those exams in a timely manner, getting the results back to the students so the students can learn from their mistakes or whatever. And so I think that's an area where certainly the digital tools, along with faculty members who are focused on the learning experience, and I mentioned, by the way, I also mentioned one of the areas that the task force emphasized was improving teaching effectiveness. And so I think that there, of course, a lot of it's just caring professors, but I think technology is something that we're using more and more and more to make that experience more effective for today's students.
Okay, for me, in your opinion, what can the school do to enhance the undergraduate experience? I think at this point it's a lot of smaller things. There's nothing, no major overhauls needed. Like the dean said, the digital resources could be a good help. I know, personally calculus, having, you go to class and then having maybe an outside lecture that's recorded online or some other outside resource just as a follow-up if you have more questions kind of thing. Just so you're getting more help from professors and from the departments without having to kind of either go find a tutor somewhere else or go off campus or things like that. That would be a really great help, I think. Trying to think of what else. I mean, overall, living on campus definitely makes us all grow and learn a little bit. Brings us all closer to class too, so it's much easier to get to and from class and make sure we have study spaces. The library edition definitely helps. More study space on campus. Yeah, I think so.
For me, if you were able to garner greater funding, where would you like to increase spending? Always like to garner greater funding. So funding comes. There are two ways to target funding. One is funding to enhance, improve what we have, and then funding for new initiatives. So let me focus first on funding for what we have to make it better or to sustain a lot of the things that we're doing. When it comes to funding, right now, the biggest challenges that we face in terms of funding are funding to recruit faculty. Getting the very best faculty has become very, very expensive. Not only do they demand higher salaries because they're very, very good, but also they demand really nice labs in which to do their work, and they need to have startup conditions so that they'll be successful. So when I hire a new faculty member, I want that faculty member to come in. I want them to have a nice lab. I want them to have some funding, some seed funding, so that they can hire a couple students, get the equipment that they need, and ultimately be successful in bringing in their own funding, which is the ultimate goal there. Faculty are the most important thing that we have. If we have outstanding faculty members and we give them facilities in which they can be successful, we will continue to attract students like Kristen. If we don't have faculty members like that, working in facilities like that, we will not attract students like Kristen. It's that simple. So I'd say that my biggest challenge is faculty, being able to hire the very, very best. And then, of course, the next thing is if you do hire the very, very best, they're very marketable. So you need to keep them. So that's a huge expense, and the infrastructure associated with that. Staff also, we do not have enough staff at Tulane to do the kinds of things that our research is growing, and we need technicians, we need accountants, we need lots of people to support that mission. So those are the challenges. I think that in terms of new initiatives, I mentioned earlier on that I do want to expand the footprint of engineering here at Tulane University. I've been very clear about that from the day the School of Science and Engineering was formed. And so I told my board of advisors last week that in addition to continuing to make sure that our science base and our existing engineering programs are strong and getting stronger, I do need to garner resources for some new initiatives to bring in more engineering programs where they make sense for us, and most importantly, where they can be nationally competitive. That's really important to everything we do at Tulane. So I think we are out of time. I hope we got to all of your questions. I'm sure there are some that we didn't. And I'll look at those and I will put them on the agenda for next time. But again, the next webinar, please tune in. It will be focused mainly on interdisciplinary collaboration here at Tulane University and how the SSE plays a role in that. Thank you for tuning in.